Okay, Algebra Honors, this is our Unit 6, Day 9 warm-up, and this is our second video, so we're just doing the back half here. So if we need to find the area of a rectangle, we know the length is square root of 2, the width is 4 roots of 6. So I know if I have a rectangle, the area equals length times width. Right, so I know the length, I know the width, so I'm going to say my area equals length times width. And so now I'm going to do this math that I can do. So I can multiply under the radical. So I'm using the product rule to recombine those guys under the same radical. So I have 1 times the square root of 2 times 4 times the square root of 6. So my outer numbers are 1 and 4. 1 times 4 is 4. And then under the radical, I'm now going to say square root of 2 times square root of 6 together, so that's square root of 12. But I know that I can simplify that. That's 4 times the square root of 4 times 3. So that's going to be 4 times 2 times the square root of 3, which is 8 roots of 3. Okay, not the only way to do that, but that is a way. Okay, if I need the area of a rectangle with length of square root of 3 and width of all of this, recommend you use parentheses here so that you don't misplace anything. Area equals length times width, so I'm going to say square root of 3 times all of my width, 5 roots of 3 plus 2 roots of 6. And now I'm going to use distributive property. So square root of 3 times 5 times square root of 3, that's going to be 5 times, I'm just rearranging the order. Okay, square root of 3 times 5 times square root of 3 plus, this is square root of 3 times 2 times square root of 6. So I'm rearranging the order again because then I have my radicals next to each other. Here, 5 times the square root of 3 times the square root of 3, well, that's really 5 times 3, right? Plus 2 times the square root of 6 times the square root of 3, that's 2 times the square root of 18. Okay, 5 times 3 is 15. I'm coming up here now. 15 plus 2 times the square root of 9 times 2. 15 plus 2 times 3 times the square root of 2. And I have 15 plus 6 roots of 2. That is my area. Okay. Multiplying radical expressions. So we always want to double check that we have the same index here. So I have square root of 7 times square root of 5. That's going to be the square root of 35. And I just want to make sure there's not any way to break that back down in a different way. There's not. 35 is 1 times 35 or 5 times 7, right? So no perfect square factors in there. Over here, square root of 3x times square root of 10, that's going to be the square root of, I get to multiply 3 times 10 and get 30, and then I'm just going to say xy. I didn't say square root of 10y. Sorry about that. It really is square root of 10y. I think to myself, 30 is 1 times 30, no perfect squares. 2 times 15, no perfect squares. 5 times 6, no perfect squares. So that should be the end of that. Okay, these have the same index. They're cube roots, both. So I'm going to say with the product rule, I can multiply everything together. I have 3 times 5 is 15, and y times y is y squared. So remember, I'm looking for things that have perfect cubes as factors. And 15 is 1 times 15 or 3 times 5. No perfect cubes in there. Y squared doesn't have a big enough exponent to break down, so that's it. That's what I do. Multiplying and simplifying, so there's my hint that I'm probably going to have to simplify as well. So I'm going to multiply 10 times 20. This is how I would do it. I know that I could simplify the square root of 20. That's really 2 times the square root of 5, right? I'm not going to do that yet. I'm going to rewrite this as the square root of 10 times 20, so 200. And now I know that's the square root of 100 times 2, right? So it's going to be 10 times the square root of 2. You could do it the other way, and you would eventually get to the same answer. But I kind of think that's the easier way to do this. Okay, here, square root of 6x times square root of 15x. I'm going to say that's the square root of 90, there you go, times x squared. Okay, I'm going to rewrite that as 9 times 10 times x squared, because now I see perfect squares. It's going to be 3x times the square root of 10. All right, over here, cube roots. So I get to multiply. I'm going to put everything into the same house. 9 times 6 is 54. P squared times p is p cubed. And q squared times q squared is q to the 4th. Okay, so I need perfect cubes, so be careful here, perfect cubes. All right, I'm thinking about all the cubes I know, so I'm going to say this is 27 times 2, because 27 is a perfect cube. Times p cubed times q, I'm going to write this as q to the third power times q. Now I can see all of my perfect cubes and pull them out. The cube root of 27 is 3. Cube root of p cubed is just p. The cube root of q cubed is just q. And I could not take the cube root of those remaining factors in there, so I'm just going to keep them inside as the cube root of 2q. Okie dokie. Now we're going to divide and simplify radicals. Divide and simplify radicals. I typically will simplify inside that radical first if I can, and I can see that 7 goes into each of those. 7 goes into 28 4 times, and 7 goes into 70 10 times. Okay, now I'm going to write that as the square root of 4 over the square root of 10, and that is 2 over the square root of 10. But wait, I can't have a radical in the denominator, so I'm going to multiply it by square root of 10 over square root of 10. And my answer is 2 roots of 10 all over 10. But wait, big alert, right? I can simplify 2/10. So it's really the square root of 10 over 5, right? 2 goes into 2 1 time, and 2 goes into 10 5 times. There's my answer. Okay, here, let me go ahead and simplify that denominator. I'm going to have x times the square root of y here. And my denominator, if I take out x squared, and take the square root of x squared, I have x times the square root of x. Okay, because that's the square root of x squared times x, so I took out the square root of x squared, which is x. So now I get to cancel those x's. I have the square root of y over the square root of x, and I can't have a radical in the denominator, so I'm going to multiply to get rid of it. My final answer is the square root of xy all over x. I put x first there just because I like my variables in alphabetical order. Okay, all of this. Here's what I'm going to do. That's going to be 9km square root m. I pulled out the square root of m squared. This is going to be 7k square root of m. I pulled out the square root of 49 and the square root of k squared. Okay, square root of m divided by square root of m is just 1. K divided by k is just 1. So hopefully 9m over 7 is my final answer. Thank you for watching.